Hello everybody, this is 2013, question number 5 for BC only. Let's have some fun. Fun. So they want this limit. So let's do this. Now, there are some things you have to be very careful about on this. Just some, it's easy to write something incorrectly, and I'm going to point that out. So we want the limit as x approaches 0 of f of x plus 1 over sine x. Now, f of 0 is negative 1 plus 1, so this top is going to come out to be 0. And sine of 0 is 0. So you can get 0 over 0. This is what you do not want to do. Equals 0 over 0. That is an incorrect statement and will lose you a point. Because the limit never actually reaches 0. X never reaches 0. X approaches 0. So this never actually equals this. It might be undefined. So I guess technically it could be true, but you don't know. This is a L'Hopital's case. When the top and bottom both approach 0 or infinity, it's L'Hopital's, and it doesn't necessarily mean it's undefined, so don't do that. So you have to show it's L'Hopital's. So what you need to do is show that the limit of the top, so the limit as x approaches 0 of f of x plus 1 equals 0. And the limit as x approaches 0 of sine x is 0. So you show that it's 0 over 0, and now you can say, therefore, by L'Hopital's, this equals the limit as x approaches 0 of f prime of x. You take the derivative of the top, and you take the derivative of the bottom. Now, the f prime of 0, they give that to you. They tell you, no they don't. We have to calculate that. So, side work, dy dx when x is 0 equals, so it's y squared. So y we know is negative 1 when x is 0, and 2 times 0 plus 2. I'm just using the derivative formula down here. So this is 1 times 2, so we know this is 2. So the top limit is 2, and cosine 0 is 1. There's my answer. Parte is finito. Let's go to part B. Euler's. Oi! I will do B over here. So we're going to make a wonderful table. Wow, it's a beautiful straight line. You like that, huh? That's ugly, but sorry. I don't have a steady hand. You're doing 2 steps. If you're doing 2 steps, that means you need 3 vertical lines. We're going to have a value x, y, and then your delta x's. Then you want your derivative, and you want your delta y, and that times that equals that. So you're starting at point 0, negative 1. If you're going from 0 and you're ending at 1/2, and you're going in 2 steps, 0 to 1/2 divided by 2 is 1/4. So your delta x's are going to be 1/4. So if you go from 0 and add 1/4, your new x is going to be 1/4. And if you start at 1/4 and you add 1/4, your new x is going to be 1/2. We can do that. So we want dy dx at 0, negative 1. We actually found that. We found it right here. It's 2. That's 2. 2 times 1/4 is 1/2. So I start at negative 1, and I increase by 1/2. That's supposed to be a half. that what we found? 1/2? Yeah. 1/4 times 2 is 1/2. So my y is going to increase by 1/2. So if you start at -1 and you go up 1/2, you're going to be at -1/2. Now, side work, I need dy dx at my new location here. So that's when xy is 1/4 -1/2, which is going to be y squared, which is -1/2 squared, 2 times x, which is 1/4, plus 2. That's ugliness. 1/4. That's going to be 1/2 plus 2. Really? Really? Is it that ugly, or am I just messing up? Wow. Which is 1/4. So it's going to be 4/4, 5/4. Really? Is it that bad? Is it 5/16? Wow, I find that hard to believe that they would get something that ugly. But let's see how it works out. So that's going to be 5/32. So -1/2 plus 5/32. Wow. I guess I could just leave like that, but I want to make sure my answer's right. I don't know. So I need a common denominator, 32. That's 16. So that's going to be -11/32. That's the right answer. So again, this will be -1/2 plus 5/32. That's my answer there. You don't have to simplify that. So you could state as your conclusion, I'll put it here, therefore, f of 1/2 is approximately equal to -1/2 plus 5/32. Dunno. That's it. All right, let's do part C. So find the particular solution to the differential equation, to this differential equation. They want this to be the solution. Basically, they want what f of x equals so that when you plug it in here, so you plug y here and you plug y here, the left side equals the right side. That's what it means to be a solution. So we're starting with dy dx is y squared 2x plus 2. And normally, if you have dy dx, to solve for y, you just integrate both sides. But here's the problem. Y is your function. X is your variable. Well, that's fine, your variable. But we have our function on the right side. That's no bueno. You can't just integrate normally. You have to recognize this as separation of variables. If you don't, you're going to lose all 5 points here, and that would be very sad. So you have to realize when your variable, y, your function y, your function, the top's your function, bottom's your variable, when your function appears on the right, you have to separate your variables. So we're going to get the y squared on the left, and we're going to get the dx on the right. Look at that. We got 1 point just for that. Next, we want to integrate both sides. And be careful. The left side is not ln of y squared. I'm going to show you why. To get that, you'd have to make u y squared. Du would be 2y dy. You would need that here. There's no way you're going to get 2y dy there. So therefore, you can't do u sub. Therefore, you can't get du over u to get the ln. So that just doesn't work. Don't do things out of habit. This is a rewrite situation. You're going to move the y to the top. On the right side, I'll find the antiderivative. It's just x squared plus 2x, and I need the plus c. So here's the deal. You get 1 point. Actually, both antiderivatives is 1 point. But having the plus c would be a point in this particular year. They don't do that anymore. So basically on a modern test, this is probably 1 point for this step. So the antiderivative of y squared, you add 1 to the exponent and divide by that. I will now multiply both sides by -1. I will now, actually, let's just at this point solve for c. So this is side work. So you'll get a point if you solve for c. You're told f of 0 is -1. So you're given the point 0, -1 is a solution to this equation that we've found so far. So I'm going to plug in -1 for y, 0 for x. Wow, that's easy. All those will be 0. So this will be -1 to the -1 is the reciprocal. 1 over -1 equals minus c. -1 equals minus c. c equals 1. So at this point, we're going to take our c that we found, and we're just going to plug it in for c. And we're almost done now. We will now take the reciprocal of the left side and we reciprocal both sides. Which, that's basically your answer. Now, they actually simplified this. I don't think you need to go any further. This should give you full credit. But if you want to know how the scoring guideline got their answer, they factored out a -1. Then they realized this is just a perfect square. So then they get this. Now, I'm not 100% sure, but I believe this is not necessary. This is sufficient. So that's it. We're done with number 5.